All right, hello everyone. I'm happy to be here at this charming event. So most of the new rules in SwiftLint need to be enabled explicitly because they're opt-in. And they are opt-in because we try to avoid surprising people with new violations after updating SwiftLint to a new version. However, often new rules are therefore overlooked because people just don't check the changelog for new rules, or they don't update their configurations. I think that they are missing out of very new useful rules if they don't consider the new ones. So let's explore some of them today. But before I start, let me introduce myself. Who am I in the first place to tell you about SwiftLint? So at my day job I do many things, but nothing of that has any relation to SwiftLint or Swift even. I'm currently even working on agentic AI use cases to integrate them in our existing systems. But previously I was very much involved in domain-specific languages, validation of these languages, and also code generation. And that got me interested into language tools in general. And since my day job at that time also involved dealing with very ancient technologies from the 1980s, I wanted to work on something more modern. So I had a look into Swift, and now SwiftLint and Swift, combining my interest for language tools, it's just a natural progression. So I started contributing to SwiftLint until I became one of its maintainers, and now, since for 2 years, I've become its maintainer because the other maintainers who were active before me, they had to do other things and became more and more involved in other topics, so I took over the lead of the project. You see it also in this contribution graph. The orange line is my contributions, and you see that around 2 years ago I took basically over the lead. What is SwiftLint in the first place? I guess that you have all heard of it or are even using it. It's one of the most popular Swift projects on GitHub with more than 19,000 stars. It comes with 250 built-in rules. Swift syntax is predominantly used for parsing, analysis, and also automatic corrections if you run it in that mode. And now here comes the problem. 60% of the rules are disabled by default. It means you need to explicitly enable, put them into your configuration to have them working. About a third of the rules support automatic corrections. It builds with Swift Package Manager, Xcode, and nowadays also very important, Bazel. It comes with a build tool plugin, with a command plugin, and it runs on macOS, Linux, and now, and I'm happy to announce that, also on Windows. There is a pre-release or release candidate available on GitHub ready for testing. And if you can spare a minute, please give it a try on any platform that is at your disposal, because a lot of internal changes had to happen to make it usable on Windows, and they might also influence other platforms. So if you can spare a minute, please check it and give me feedback. Okay, so this is a list of all the 250 rules in SwiftLint. 5 of them are highlighted, and these are the ones I'm going to talk about now. I will do it a bit hands-on with some examples just to show you where the rules trigger and where they would not. Let's start with async without await. Which says that if you don't use await in a function scope, then you can also remove the async keyword. Of course, this has implications also on the core side, but here we provide automatic fixes. It would just remove the keyword. The same here for disclosure type, because it's immutable, it's a let declaration. We can check the body and say that here there's no await. And we would not trigger for the new concurrent annotation because it requires async. Then here we don't trigger because the variable is mutable, and it might be that it gets assigned later on, so we cannot check all of the assignments whether they are using await or not, so here we need to skip it. Then if inheritance is involved, we need to keep it. And this example is about the initializer in an actor. Here we also don't touch the initializer if it has an async. I mean, here it's obvious because there's an await, but even if we remove that, there is still an implicit await, and therefore we need to keep the async here. Next up is blanket disable command. This is actually enabled by default because it's so important, and it's about the scope you are disabling in your files for certain rules. So if you would do it like that, it would apply to the whole file, everything that comes after this code. So we encourage you to re-enable the rule after a certain range of code. Or you can also be very explicit about it and only add the disable commands at specific lines, before, after, previous, or this line exactly. We don't trigger, of course, when we disable the rule itself. Might make sense for a file to disable a rule, or for certain rules we also don't trigger because they validate the whole file, so like file length or file name, it wouldn't make any sense to force you to re-enable it. Then this is a very new one, incompatible concurrency annotation, that says if you, with your library code or so, still support the Swift 5 language mode for consumers, and you're using one of these new concurrency features like the add sendable attribute, global actors, the sendable generic parameters, and so on, sending keyword, then you should add the pre-concurrency annotation to your declaration to make it usable in Swift 5 language mode as well. Here it's the sendable attribute, and here it's a sendable generic parameter, where we should also use pre-concurrency. And we don't trigger if any of these declaration is not public or open, because then there cannot be any consumer using that code. So here, if it's internal package or private, then that's fine. Next up is superfluous else, which says that if the previous scope of an else block already exits the current function scope, then you don't need the else block to write explicitly there, so we can remove it. Same here, we throw an exception, so we would exit, no need for an else block. And we don't trigger, if there is no exit in the previous block, or there's not enough exits here, only one branch would exit, not the other one, so we cannot trigger here. Last one is unused parameter, and I like that a lot because it says that if you are not using a function parameter, then you also can just get rid of it. The compiler would tell you if this applies to local variables, but it doesn't put a warning there if it's a parameter. Or if, for example, it is in conformance, so you need to have the parameter, it suggests to add the wildcard underscore replacement character instead. And of course, no violations if we are actually using the parameter in the code. Okay, that's it for the rules I wanted to show you, but there's one more thing I want to tell you. And this is the special all keyword that you can use in your configuration. And this is going to change the rules because it says that, so you put into your configuration, in the opt-in rules section, you put the little all, and it says that from now on, all the rules of SwiftLint are enabled. And you only list the ones that you don't like, that contradict each other, or that cause too many violations at the moment in the disabled rules section. And this has two advantages. First one is that you don't need to check the changelog for new rules, because SwiftLint will let you know if there are new rules. You run it with a new release, then you see it immediately that there are new violations, and you can decide on what to do. And second advantage is you don't need to reason about, is the rule now opt-in or is it enabled by default, where do I need to put it, because all the rules are now enabled and you list the ones explicitly that you want to have disabled. I highly recommend using that. And that's one keyword to rule them all, and I promise this is going to be the last pun of this talk because this is also my final slide. If you want to get in touch with me, you can find me on GitHub and Mastodon with my handle simply Denny. And with that I say thank you for having me.